In this video, we'll look at prime factorization method for simplifying surds. We had snippets of it in the last video, for instance, but here we'll go fully into it. Let's see how that goes. So prime factorization method for simplifying surds. The lesson outcome by the end of this lesson, students should systematically simplify surds using the prime factorization method with full accuracy and confidence. So if you didn't quite get it very well in the last video, this is another opportunity for you to come to terms with it way, way better. So again, we keep reminding ourselves of what a surd is, and we say that a surd is a square root or higher root that cannot be simplified into a whole number. That's another way to look at it. So a surd is a square root or higher root that cannot be simplified into a whole number. That is, it is a root that cannot be expressed in rational as a rational number. So we have examples like root 2, root 3, root 5. And a non-example will be something like root 4 or even root 16, which gives 4. Root 4 gives 2, which are rational numbers like that. So the question now is, why do we use prime factorization? So the prime factorization method is the most reliable and systematic way to simplify sorts. So, before I began to explain prime factorization. What I was doing was to because of my familiarity with some numbers, like maybe when I see 50, I know that's 25 times 2. What if you see a number like 198 or some number that you're not so used to? So the surest way to go is to use prime factorization. So it is the most reliable and systematic way to simplify sets. It works because square roots come out in pairs. So you can see square roots coming out in pairs, and then each pair of identical factors forms one number outside the radical. So that's why it actually works. We have some steps. The first step in using prime factorization, you can have a factor tree. I've done the whole tree thing in the last video. I'm going to do it again here. So a factor tree breaks a number into its prime factors. So for instance, if you want to factorize 72, 72 is 2 times 36, 36 is 2 times 18, 18 is 2 times 9, 9 is 3 times 3. So at the end of the day, you have 2 times 2 times 2 times 3 are 72. Or to do it in a more methodical way, you have 72 here, all right? And then you want to get you want to express it as a product of its prime factors. Of course, because this is an even number, 2 can divide it. So 2 in 7 is 3, remaining 1. 2 in 12, that's 6. Then again, 2 goes in 36 because it is still even. So 2 in 36 is 18. Then 2 again can go, we have 9. Then 3 can go in 9. You have 3. And finally, you have 3 goes in 3. That's 1. So you can express 72. All right. You can express 72 now as 2 times 2 times 2 times 3 times 3. So that is actually 2 raised to power 3 times 3 raised to power 2. So that is 72 right there. So that's the idea of the factorization of the tree. Okay? Factor tree like that. So after you do the factor tree thing, the next thing you want to do is to group in pairs, right? So when simplifying square roots, every pair of identical factors comes out as one number. For instance, for 72, square root of 72 is square root of 2 raised to power 3 times 3 raised to power 2. So if you group in pairs, you have 2 raised to power 2, and then you have an extra 2, and then you have 3 raised to power 3. So that's the grouping. So if I go to the worksheet and do my own version of what that should be, so it means that square root of 72 is equal to square root of 2 raised to power 3 times 3 raised to power 2. And that's the same thing as square root of 2 raised to power 2 times 3 raised to power, okay, 2 raised to power 2 times 2, all right, times 3 raised to power 2. We are interested in only the ones with power 2 because we are dealing with square roots. If you are dealing with cube roots, you are interested in power 3, for instance. We are going to see that later in the next video, I believe. So now this is like 2 raised to power 2 times 3 raised to power 2 times 2. So this one is going to be under the radical at the end of the day, you know. But let's go on. So that's the grouping thing we have done now. So the next thing you want to talk about is then converting grouped factors outside the radical. Okay, so from two multiplied by two, you pick one. From three multiplied by three, you pick another one, and then you have two left under the radical, right? So you then have each pair moves outside the square root. You have root 72 now is 2 times 3, root 2, and everything together is 6 root 2, which is the final simplified answer. So if I do that right here, then I have this now. So I can even break it down and say square root of 2 raised by 2 times square root of 3 raised by 2 times square root of 2 alone. So square root of 2 raised by 2 is 2 because this is power cancels root. So you have 2 times 3 times root 2, and then 2 times 3 is 6. So you have 6 root 2 as the result right there. That's the same thing we got here. Okay, so why does this work actually? It works because the square root of a times a is equal to a. Example, square root of 9 is square root of 3 times 3. And since you're dealing with square roots, since a square is actually a number that is obtained by multiplying another number by itself, then the square root of the square is going to be one of the number that you multiply by itself, basically, which is 3 for 9 in this case. Okay, so we have fully worked examples now. You want to simplify root 48. So you prime factorize, you have 2 times 24, then 24 is 2 times 12, 12 is 2 times 6, 6 is 2 times 3, and then at the end of the day, you have 48 as 2 times 2 times 2 times 2 times 3. That's 2 raised to power 4 times 3. And then if you group, you group in pairs now. You have 2 raised power 2, 2 raised power 2. So you have two of each of these two coming out, and then only 3 is going to remain at the end of this. So you have 4 root 3. So if I'm going to do it on the worksheet, so I have square root of 48, right? So to do square root of 48, okay, first of all, we have root 48. We get the factor tree because it's even. So 2 goes, so you have 2, that's 24, 2, that's 12, 2, 6, 2 again, that's 3, and finally 3, that's 1. So that 48 now is equal to 2 times 2 times 2 times 2 times 3. So, and that's the same thing as 2 raised power 2 times 2 raised power 2 times 3. Okay, and then square root of 48 now is equal to square root of 2 raised power 2 times square root of 2 raised power 2 times square root of 3. So that is 2 will come out of here, 2 comes out of here, and you have root 3 here, and that is 4 root 3 like that. So that's 4 root 3 for 48. So if you have another example, dealing with 180 now. 180 is 2 times 90, 90 is 2 times 45, 45 is 3 times 15, 15 is 3 times 5. So at the end of the day, 180 is 2 times 2 squared, 3 squared times 5. So that, of course, you then take the square root of that, and you get square root of 180, that's square root of 2 squared times 3 squared times 5. So from this pair, you have 2 times 2, 2 times 3 times 2. I mean 3 times 3. So you pick one of this, you have 2, pick one of this, you have 3, and then root 5. So everything goes to 6 root 5, and that's square root of 180. Well, I like to still indulge you and do this right here. Square root of 180, right? So we need the square root of 180. Again, you have 180. So 2, that's 90, 2, 45, 3, 15, 3 again, that's 5, and 5, that's 1. So that 180 is equal to 2 times 2 times 3 times 3 times 5. So that square root of 180 then, of course, this is 2 raised power 2 times 3 raised power 2 times 5. So that's the square root of 2 raised power 2 times square root of 3 raised power 2 times square root of 5. So square root of 2 raised power 2 is 2. Square root of 3 raised power 2 is 3 times 5. So that 2 times 3 is 6. So you have 6 root 5. And that's what 180 ends up giving us. And then we can also extend this idea to cube roots. Okay. In the next video, we'll be talking about higher roots. So watch out for that. So for cube roots now, you can group factors in threes instead of pairs. So square roots group in pairs, cube roots group in threes, fourth root group in fours, like that. So imagine you want to find the cube root of 54. So the prime factors will be 54, that's 2 times 3 raised to power 3. So cube root of 54 is now, so for this 3 raised to power 3, 3 comes out and you have a cube root of 2 as the radical. But let me still go and do it on the worksheet. That's root 54, like that. I mean, cube root of 54. So let's talk about cube roots of 54. So we need a cube root of 54. So what do we do? Let's factor 54. 2 goes here, that's 27 here. 3 goes, that's 9. Yeah, that's 9, of course. Then 3 goes again. That's 3. 3 goes one more time. That's this. So we have 54 equals 2 times 3 times 3 times 3. So because we are dealing with cube roots, we are interested in having these 3. 3 raised by 3 here. So that cube roots of 54 is equal to cube roots. That'll be cube roots of cube root of 2 multiplied by cube roots of 3 raised to power 3, because power 3 cancels cube roots, right? So we then have 3 here multiplied by cube roots of 2. Mind you, cube root of 2 is not the same thing as 3 root 2. So they are not the same. So watch out for that. So square root of, I mean, cube root of 54 is 3 cube root of 2. Okay, so you can see the 3 is hung within the root sign. This root sign, so to show that it is cube root. So that's how that goes. So our systematic summary for this will be this. For any square roots, you need to draw a factor tree until all factors are prime. Then write the number as prime factors. Index form will help in this case. Then group identical factors into pairs. That's for square roots. Then move one number from each pair outside the square roots, like we've been doing. Then multiply outside numbers together, and then you multiply by the radical, and we are good. Then common mistakes to avoid. Stopping factor trees too early. So if you don't factorize completely, it's going to be a problem. Then forgetting to group properly. So if you have a group of 3 and you just take one out without paying attention to the fact that there's still another number left, that's going to be a problem. Leaving pairs inside the radical. If you leave pairs inside the radical, you're still going to have a perfect square or a perfect yeah, you're still going to have a perfect square under the radical, and that's not going to give you the basic radical, the simple radical form. Then not simplifying completely is another problem right there. So let's look at some practice problems. Simplify each fully using the prime factorization method. I think I'm going to go for question 10, root 75. So we want to factorize, we want to use prime factorization. So square root of 75, square root of 75. So we need to do square root of 75. Of course, if you don't write any, you could write 2 here for square roots, and you could leave it blank, because if you leave it blank, we know it's square root automatically. So now we have 75. So 2 cannot go in 75. 3 can go. 3, because 7 plus 5 is 12. So 3 can divide 75. 3 in 7 is 2, remaining 1. 3 in 15 is 5. Then 25 now. So 5 goes in 25. 5 times 5 goes in 5 one time. So that 75 is equal to 3 times 5 times 5, which is 3 times 5 raised to power 2. So we need the square root of 75. So square root of 75 now is square root of 3 times square root of 5 squared. Like I said, square cancels roots. So we have 5 root 3 for 75. So let me take one more question from, or let me see if I need to take more than one. Okay, not necessary to take more than one. So now let's take a number that might be quite um let me take 192, right? Let me take 192, square root of 192, square root of 192. So for the square root of 192, right? We need square root of 192. So what do we do? Again, come and do the factor, right? The prime factorization. So you have 192 here. Okay, so 2, that's 96, I believe. Yeah, that's 96. Then 2, that's 48. 2, that's 24. 2, that's 12. 2 again, that's a 6. 2 again, wow, that's 3. And finally 3, that's 1. Okay, I hope that's fine. 96, 48, 24, 12, 6, 3, and then 1. So that means that 192 is equal to how many twos now? One, two, three, four, five, six. Oh, that's 64 times 3. Makes sense. So that's 2 times 2 times 2 times 2 times 2 times 2. Hope that's not too much. Yeah, that times 3 now. That's 64 times 3. So that means if you are going to, since you are going by the way of square roots, so we have 2 squared times 2 squared times 2 squared times 3. Okay? That way, so square root of 192 can then be square root of 192 can then be equal to square root of 2 squared, first one, times square root of the next 2 squared, this one, times the square root of the third 2 squared, times square root of 3. So we then have 2 times 2 times 2 times root 3. So that's 8 root 3, like that, 8 root 3. So that's how square root of 192 goes. And with this, we come to the end of this interesting video talking about simple prime factorization method for simplifying sorts. So any number you have at all, you can just use rules of divisibility to deal with to factorize completely any number whose roots or cube roots or fourth roots you may be looking for. Interestingly, in the next video, we'll be looking at higher roots like cube roots, fourth root, fifth root, and the rest of them. So you want to watch out for that. So I come to the end of this video. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I thank you very much for doing that. If you haven't subscribed, why haven't you done that? Why not go ahead right now? Subscribe and hit the notification bell so you can always get alerted each time a new video is released. And don't forget to try your hand on this practice questions, to try to simplify and see how things go. Okay. Ultimately, I mean, you can also become a member of the channel, by the way. You can become a member of the channel by clicking on join. So click on join. That gives you special privileges like seeing some videos first before others see them, or being the only one to see some videos because you're members of the channel. Then you could also request for PDF copies of my notes. As a member, you can also hang out together to discuss whatever interests you on this channel. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.